Okay, when we see this series, here's what we should be thinking. Here's what you should be thinking. We talked about this in class a little bit. But you should be thinking that the sine of 4n is always less than, the absolute value of sine of 4n is always less than or equal to 1, because the amplitude of a sine function is just always less than or equal to 1, right? So when you're thinking about this series here, sine of 4n, 4 to the n, you should be thinking about comparing it to 1 over 4 to the n. Now, this series that we just wrote is geometric. What is the ratio? The ratio is 1/4. So this series is going to converge. And this is pretty much the reasoning that we'll use. So what we'll say is our series sine of 4n over 4 to the n is absolutely convergent because, let's look at the absolute value of these terms. So sine of 4n over 4 to the n, the absolute value is going to be the sum, absolute value of sine of 4n, all divided by 4 to the n, and by the direct comparison test, our series with the absolute value of sine 4n over 4 to the n converges because the absolute value of sine of 4n over 4 to the n is less than or equal to 1 over 4 to the n and greater than or equal to 0 for all n, right? And so our geometric series is going to converge. So there we go. The series is absolute. That's our answer, AC.